The following is a short introduction and demonstration of the zero-latency traffic shaping feature found in Accedian Networks MetroNID demarcation units.
Okay, so we have a setup here today to demonstrate the traffic shaping feature in our Accedian MetroNID TE product. We have one installed over here in our Ether shelf, which is a 4U 12-unit rack-mountable power source. What we're going to be doing is sending traffic in bursts into the MetroNID using the JDSU FST 2802 test set. And the whole basis behind this traffic shaping feature is that even though traffic may come in bursts and exceed the service level agreement between the carrier network and the client, no frames will be lost, and the traffic shaper will be able to flatten it out so that it doesn't exceed this SLA. So in our setup here, as I mentioned, we're going to be using the JDSU test set. I'm going to send 2,000 packets at 10 megabits per second, and we'll see in the rate later once it's actually running that the transmitted rate exceeds 10 megabits per second. However, we will still be receiving at the 10 megabit per second without losing any frames. That is the end result, and that's what we want to see, that the feature is working properly. I'm also going to be using Wireshark Network Analyzer to show kind of in a graphical visual form the traffic incoming to the MetroNID in bursts, as well as that'll be coming in on this display here. And the laptop here will be showing the outgoing traffic as it's being shaped and kind of flattened out. So maybe we can just start the test up here. I'll show you the display here on the test set. Basically, when we start this test, we can see that it's going at 2,000 packets being transmitted at the same time. And over here, we will see the transmitted rate is actually exceeding the 10 megabits per second. It's going to 11.3 in its bursts. However, we can see here on the received megabits per second that we're always receiving at 10 megabits per second. And you can see here it's kind of coming in not in bursts, of course, it's coming in continuously. So graphically what this looks like, we can see over here on this display here, these are the peaks in the bursts of traffic as it's coming through. However, on this display over here, as it's coming out of the MetroNID, we can see that there's a lot less peaks, and it's being flattened out to a more consistent frame rate. So this kind of shows that the traffic shaper is doing its job right now, but really to be sure that it did its job properly, when we stop the traffic here, we should be able to see that the transmitted frames are equal to the received frames, and that we haven't lost one frame. So when we stop it, you can see it takes a little time to catch up, but there we have not lost one packet or one frame. So this kind of this shows that the traffic shaper feature has done its job. So we've complicated the setup a little bit more by introducing a new stream of traffic into to go into the MetroNID. This stream is going to represent a more stable, constant, say, latency and jitter sensitive stream, such as via voice over IP. So I've got this set right now. This is the Sunrise Sunset NTT test set, which is going to send 500K bits per second of constant stream of data. Again, we're going to use the JDSU test set to send the burst, the 2,000 frames at 10 megabits per second, and we're going to combine both of those into the switch here to be able to send that out in one stream of traffic into our MetroNID. into our MetroNID. So we've also introduced two EtherNIDs. These are simply being used for media conversion here from electrical to optical, and The other one is being used for loopback with a MAC swap, MAC address swapping, so that the switch can do its job and send the traffic back to the proper test set. If we start this up here, what we're going to see over on our displays over here this time, we're again using Wireshark for the graphic display. On the laptop, we're going to be seeing the burst traffic this time. So we'll again see the peaks happening as the bursts of traffic are submitted. And on the LCD here, we're going to have a combination of both the bursts after the shaping and the constant stream of 500k bits per second. And that the constant stream of 500k bits per second will be displayed in a red color, where the shaped traffic will be in black. So if I start these tests up here, we'll see that the burst traffic will again be shown over on the laptop here. So we can see the bursts happening. And this is the output as it comes out of the MetroNID after being shaped. So you can see it's a little more flat compared to the bursted traffic over here. So now I can start up the constant stream of data here, which will be shown down here in the red line. So we'll see this is fairly flat the whole way across, as it's just constant 500k bits. So what we're seeing right now is that the shaper is actually doing the shaping in for the bursted traffic, where the constant stream is going through our real-time queue and is not being affected by the shaping traffic shaping feature. This will be apparent later when we look at the statistics to be sure that no packets have been lost. So, let me let that run for a bit. Now, once we get to stop the traffic here, what we'll see is that there were no frames lost. However, we will be receiving some extra frames due to the inclusion of the switch here, which is going to be sending out some broadcast frames. So I stopped the traffic here, and as we can see here, it had transmitted out 7,585 packets, and all were received. The extra 3 were broadcast packets that were sent by the switch. Now over onto the JDSU side, the same thing will be seen over here, where no packets or no frames were lost. We received 1 extra broadcast frame. So this is showing our feature of zero latency real-time queue, where we had the constant traffic going through the real-time queue and the bursted traffic was going through a shaper. Okay, so to further emphasize on the zero delay to the real-time queue, what I'm going to run here on the Sunrise test set is a round-trip delay test. Unfortunately, this couldn't be done at the same time as we were doing the constant stream of 500 kbits per second. So if we still have the same bursting traffic going on the JDSU test set, we can see that the shaper is still doing its job here and bringing it in at a constant 10 megabits per second, even though sometimes it bursts over 11.8 or it bursts over the 10 megabits per second. So over here on the Sunrise test set, we'll run this round-trip delay test, and we can see the current value at the top here is keeping kind of a constant 0.075 milliseconds delay. So if we stop the traffic, stop the burst traffic, and therefore stop the shaper from doing any work, we'll see here that there's the round-trip delay is still keeping reasonably steady. There's no significant delay that was added to the round-trip delay here when the shaper was actually doing its job to the certain amount of delay added to the constant stream over here.
Thank you for your interest in Accedian Networks' zero-latency traffic shaping feature. The Ethernet Service Assurance platform from Accedian Networks offers a complete range of service assurance and service creation functionality for carrier-grade SLA-backed Ethernet and IP services.